Greetings and welcome, friends. We are continuing our look at solving one variable absolute value equations. And today we're going to be writing some of our own equations. It says, oh, check this out. It says in a cheerleading competition, the minimum length, so smallest length of a routine is 4 minutes. The maximum length is 5 minutes. And then they tasked us with writing an absolute value equation that represents the minimum and maximum lengths. Now, a moment ago, I had my students working with some graphs, and we recognized some patterns regarding these formulas, and we realized that the midpoint was related to the following. That if I have the equation, actually I'll write it in blue here, so I'll have absolute value of x minus some number equals some number, that the midpoint of my solutions was b, and that the distance the solutions were from that midpoint was c. So b is the midpoint of solutions, so b equals midpoint of the solutions, because most absolute value equations are going to have two solutions. And c is the distance b is from those solutions, or the distance those solutions are from b, whichever way you want to think about it. So when I want to solve this, the minimum length is 4. Actually, let's ask that. We've got to figure out b. Here I know the solutions. I know x equals 4 and x equals 5. So if that is the case, how could I find the midpoint between those numbers? Or maybe you could just look at it. What is the midpoint between those numbers? One way to find the midpoint is to add them together and divide by 2. It's an average. So b would equal 9 over 2, or b is equal to 4.5. So the midpoint between 4 and 5 is 4.5, which probably makes sense. And then the question is, how far is 4.5 from 5? So I could do 4 minus 4.5 to find c, which is 0.5. So let's actually graph this before I write my equation. So I'm expecting the midpoint to be at 4.5 and the distance to be 5. So let me drag this to 4.5. Let's see, this is 5. 4.5 would be right here, and I want this to be 0.5. Let's see, oh, my text is getting jumbled there. Bam. So look at that. What we have, here I'll zoom in a little bit. Ooh, lovely. McDonald's, delicious. I'm loving this too. This is amazing. So what I have for my solutions, notice I do in fact get the same solutions at 4 and 5. The midpoint is at 4.5, and that the distances I traveled, right, was 0.5 units. So the equation will be of the form x minus b equals c, or abs x, sorry, I forget the abs part. The absolute value of x minus 4.5, because it's the opposite of this number, remember, opposite there, is equal to 0.5. Sorry. So this equation would represent this situation. It models it correctly. The average time is that, and the distance from the average time at most was 0.5. Right, Devin, you tracking this? Okay. So that's a little bit tricky getting used to that. Feel free, internet friends, you could just copy this link and I'm sure it'll take you there. It's shareable. And so if you want to use this as a tool to help you graph those, you can. So let's try question 7 real quick. The monitoring progress, question 7. Well, you can do 7 here. All right, guys. Devin, You can turn around. For a poetry contest, the minimum length of a poem is 16. The maximum is 32. So I could view those as like my solutions. X is equal to 16 or X equals 32. They want the absolute value equation. So what will B equal? Yeah, add them up, divide them by 2. Or you might be able to just look at those and figure out the average. I don't know. 16 plus 32 is 48. Divided by 2 looks like B equals 24. I agree. And C is going to be the distance that either of these are from 24. So if you wanted to do it arithmetically, you could just do 32 minus 24. Or 24 minus 16. Either will work. So C is going to equal, looks like 8. And so I'm expecting my equation will be of the form abs x minus 24 equals 8. Right? Let's see what this looks like here. Let's see if I can, I'll have to zoom way out. So I drag this all the way. Oh no, I've got a max value. That's awful. I've got all sorts of equations I was writing here. So B would equal 24. Will it let me do it? I did. Aha. And then we were expecting an 8-minute. Yeah, I've got all sorts of little equations over here. Why isn't 8 working? I just wanted the 8. There we go. Aha. And I can hide my equations now so it don't scare us. And so notice that this is the graph that I end up getting. And that is the situation that we see. Oh, so I can pull it right in here. Okay. So the solutions are such, you can find the midpoint, and that midpoint is literally the thing that I take and plug in here. And the distance, right, in this case is 8. And that's literally what I take and plug right there in the equation. Right, so one of the things that's a little bit tricky is that this is the opposite of that right there. Question, comment? Might not be the best idea, but you know yourself here. Okay, last example. We're going to do example 5. So, it turns out, and we saw this earlier as well, sometimes there's just like no solution to some problems. And it turns out with absolute value equations, you might end up in a situation, Devin and Ethan, stop, gentlemen, please. You might end up in a situation in which you have a false solution. Devin, turn around and shut your mouth. Thank you. So here we got this idea of an extraneous solution where I do everything correct, but it ends up one of them or both of my solutions might be wrong. What's different about this equation compared to other absolute value equations we've had? Every other absolute value equation we've had, yeah, here's the problem, right? Adriana noticed it. This x is in a different spot. But now I'm going to try to solve this the same way. Is the absolute value by itself over here? Right? Nothing's outside of the absolute value on this side of the equation. Yeah. So let's break it up. And I've got to be careful. I'm going to do everything right, but there still will end up being a false solution, or possibly 2 false solutions. So either, get rid of that absolute value, Mr. Waddy. 2x plus 12 is equal to 4x, or 2x plus 12 is equal to negative 4x. All right, so I break it up into 2 cases. And now I'm going to solve each of these normal style. So, tell you what, I'll subtract 2x over here from both sides. I'd have 12 is equal to 2x. Don't pack up yet, Amity. Then you can sit down, thank you. So I'll have 12 divided by 2 is 6, or x equals 6. And over here when I solve, I'll move this over. Although, as long as you obey the laws of algebra, you will be fine. So I'll have 6x plus 12 What's this side equal to? 0. Yeah, it could have saved us a step. You're exactly right. Exactly right. So I'll have 6x equals -12. Divide by 6. And it looks like I've got two solutions, but I've got to be careful. It turns out if I do a check, it turns out that one of these solutions is a phony. It's what's called extraneous. That even though I did everything right, notice when I plug in 6 to the problem, 2 times 6 is 12, 12 plus 12 is 24, abs 24 is 24. That works out. This one is good. This one's great. We like that solution. Cha-ching. But over here, if I plug in -2, 2 times -2 is -4, plus 12 is 8, and this one ends up being false. So this is what we would call an extraneous solution. And that means that this doesn't count, and just the 6 ended up working. All right, well, thanks for watching, Internet friends. Have a great day. Bye-bye.